The video today should be pretty much a review. So we're going to start with this table, and it's telling us to find the rate of change. Remember, this triangle right here means change, so we need to find the change in y, meaning what's the difference between each of these rows in the table. So -10 going to a -6, we're adding 4. -6 moving to a +2, we're adding 4. Excuse me, a -2. -2 moving to 0, we're adding 2. And 0 moving to 10, we're adding 10. We do the same thing to the other side. A -2 to 0 is a +2. 0 to 2 is a +2. 2 to 3 is a +1. And 3 to 8 is a +5. So now that we've found the change between each row, we need to find this ratio, the change in y divided by the change in x. So all that means is for each row we need to find this ratio. 4 divided by 2. The next row is 4 divided by 2. 2 divided by 1. 10 divided by 5. All of these ratios equal 2. Because all of these ratios are the same, that indicates to us that it is a linear function. If they had not been the same, it would not be a linear function. So now we have to use this rate of change. This number is the first number in our process. So we're going to take the 2, multiply it by the x, which in this case we now have -4. And the end of the process is how we get from the -4 to -10, which we need to subtract 6. Now we fill in the rest of the table to be sure that our rule that we came up with for the beginning still holds true. So 2 times 0 is 0, minus 6 is -6. And if we keep going, then our rule will hold true, which means our final is 2x minus 6. So this is our equation. To turn it into the equation, you just put y equals 2x minus 6. So the next screen is going to show us the entire table all filled out. Yours should look like this, has our ratios on the side, and your next question says, is this relationship linear? And how do you know? So I discussed this on the last side, that it is linear, and we know that because all of these ratios are equal. That's how we know it's linear, because the rate of change is equal in the entire table. Our next part asks us to graph it. So you guys know how to graph. Starting with the -2, -10, we find -2, -10. Go ahead and continue graphing. So you should have dots that look like this. Your next question says, should the points be connected? Why or why not? If I were to put a different number in this table, for example 1, it's not in my table, but I could solve for 1. 2 times 1 is 2, minus 6 is -4, and the point 1, -4 could go on my graph. So our points should be connected because this is a linear function, and because I can use any value for x and find a value for y, then yes, they should be connected. Is it proportional? If you remember from 7th grade, proportional means that it would have to go through the 0. It means there's no additive part of it you learned in 6th grade as a multiplicative relationship, meaning that the x is only multiplied by something. There's no adding or subtracting in the equation. So in this point, in this relationship, no, it is not proportional. And we know from the equation, and we also know that because it does not go through 0, 0, does not go through the origin. Moving on to the slope portion of the notes, what is the rise-run ratio between any 2 points on the graph? So the rise is how much that it goes up and down. The run is how much it goes side to side. This is the same as the change in y over the change in x that we solved for from the beginning. It's also the same as taking any point on the graph and counting to the next intersection, and we're going to rise 2 spaces and run 1 space. When we look at our table, we increase 2, we run 1. So that ratio is 2 over 1. Other names for this ratio, the change in y over the change in x, the rate of change, and it's also called the slope. In our equation, remember this is our rate of change in the equation. After we solved for this proportion, for this ratio, we put it at the beginning of the process. And as we filter down, this 2 became the first number of our equation. So this 2 is the value in the equation that represents the slope. The first number, the coefficient of x. Moving to y-intercept. Intercept means a cross. Y indicates the y-axis, so the y-intercept is where the graph crosses the y-axis, which is right here at -6. It can also be asked as what is the value of y when x is 0. So when x is 0, my value of y is -6. If I look at the graph, when x is 0, not moving to the left or to the right, the y value is -6. And in my equation, it's the constant at the end of the equation, -6. So don't forget that this sign, whether it's positive or negative, belongs to the number. So the subtraction sign indicates that this is -6. Flipping onto the back of your handout, it's kind of going to walk through the same process, just with a situation. So Jonna opened a savings account with $50 she received for her birthday. She plans to deposit an additional $10 into the account each month. Complete the table, write an equation to represent the situation. So this each month part is helpful because it lets us know that that's going to be our x. So the number of months is the x. And the other changing variable would be the total number of dollars saved. So to kind of fill in our table, we have to kind of go back to the situation that she opened the account with $50. So at 0 months, that's when she opened the account and she had saved $50. After 1 month, she's going to deposit an additional $10. So if she's adding $10 every single month, now she would have $60. By month 2, she's going to add another $10. By month 6. So because this jumps from 2 to 6, we can't just go 80, 90 and be done with it. So at this point, it would be helpful to find our process to then continue the table. So we'll find our rate of change first. These are all increasing by +10. On this side, we increased by 1. So my change in y over change in x would be 10 over 1, or 10. So this is the $10 per month. So my months is my variable, which goes next. 10 times 0 is 0, plus 50. $10 for the first month, plus the $50 she opened it with would be 60. $10 for the second month, plus the $50 she originally had in there equals 70. So now we can use this to find out how much she had at 6 months. 10 times 6 is 60, plus 50 is $110. And then 10 times 12, 120 plus 50. So after a year, she had $170. And my equation would be 10x plus 50, or y equals 10x plus 50. So what I would like for you to do is to now finish the rest of these notes by reading the following questions, and then don't forget to go back to the video comments part, click on the link, and fill in your feedback.